I guess all of you have already gotten your hydroxy compound notes. Shh. Are you ready, my dear friends? Dear friends who are moving in, can you quickly? You are late. Okay, today we'll be starting on a hydroxy compound, which is a new topic for you. Okay, same thing, the tiny URL is still there. So if there's any question that you are not sure that you would like to clarify, you can also type it inside, or you can come and look for me after the lecture. Okay, so just a quick recap of what we have done so far since year 5 last year. You have done intro to organic chem. You have done alkanes. You have done alkenes in year 5 after your promos. Okay, then for the start of the year, you have done arenes, you have done halogen derivatives. So if you look at all the topics that we have for organic chem, you are almost halfway there. Correct? So we have hydroxy, carbonyl, carboxylic, and nitrogen left to complete. Okay, so please hang it there, baby. Okay, almost. We are almost finishing, okay? Almost. Okay? So, yeah. So what to expect for this topic? Okay, I think for this topic, you can take a break from your mechanism. For this topic, there isn't any mechanism for you to learn. So we will go slightly faster. You can take a break from your mechanism. Okay, before we start on the lecture proper, shh. Okay, before we start on the lecture proper, we will talk about some alcoholic drinks. I think all these are not new to you. Somewhat here, there, in your whole 18 years of life, you have probably seen it, seen it before. Beer, okay, I'm sure a lot of you know beer. Liquor, maybe not so common nowadays, and wine, red wine or white wine. Okay, so basically, this alcoholic drink, shh, are you ready? For alcoholic drink, basically, okay, it's a drink. Okay, if I define something that is alcoholic, okay, I would say that it is actually a drink that contains the ethanol, okay, a type of alcohol produced by the fermentation of grains, fruits, and other source of sugar. Okay, so you actually go and ferment it using your yeast, and then ultimately you get all the different drinks that you're supposed to have. Okay, this one is actually an alcoholic chart. So maybe some of you like certain types of wine, which you are not supposed to drink at your age. Okay, but it just shows the average alcohol level that is present and what are some of the main ingredients. Okay, so this is for your knowledge. I think the very common one that most of us are exposed of, I think it's beer and wine. Okay, it's beer and wine. Okay, if you go to a Jap restaurant, maybe your dad or your brothers who are older than you might order sake. Okay, yep. Okay, so these are just alcoholic content for you. Okay, so fermentation, probably some of you might be wondering what is fermentation. Okay, basically here, like mentioned, is the conversion of the sugar or carbohydrates to alcohol during anaerobic condition. And then, yeah, so this is an example of a person. Oops. Okay, who harvests one of the plant that is actually used to ferment your drinks. Okay, so this is a picture of it. So actually, alcohol is actually very common, or I should say we actually do see in our everyday life. It's just that at your age, I think you are not supposed to drink it yet, below 18. Okay, so yep. But I'm sure you are exposed to it before. Okay. This one may be not so common for you. Okay, it's your alternative form of fuel, your bioethanol. Probably we are not so familiar with it. Okay, basically it's an organic compound that you use to power something, a biofuel. Okay, so in practical consideration, okay, it is actually any organic fuel that you can produce in a short period of time, and then use will be called a biofuel. Okay, that is different from your fossil fuel. Fossil fuel take millions of years before you can use it as a fuel. So some examples are actually your corn, your sugar cane. Okay, all this can actually be used as a biofuel. Okay, and they actually contains the okay, yeah. Okay, and this one, okay, some of your wheat, okay, and your plant can actually be used. Okay, but then this one, there are also some controversial about it. Some people are saying that yes, it produces yes, it is good to be used, but on the other hand, they actually use a lot of land because you need to grow all this crop first before you can use them as a biofuel. Okay, so it's a controversial issue that people is talking about. Okay, whether you want to believe in biofuel or not. Okay, so that is some of the science related to this topic. Okay, okay, so let's go into your content proper. Okay, content proper. Basically, in this topic, what you will be asked or you need to know is actually the identification of the different types of alcohol, which is namely your primary, secondary, and your tertiary. Okay, and then your physical property of your alcohol, boiling point, solubility, how to prepare alcohol. Actually, this is related to what you have learned in the past. Reactions of alcohol might be something that you have not learned it before and you'll learn in this topic. And another class, which is phenol. Okay, phenol is a benzene ring attached, bonded to the OH, or I should say the OH is directly bonded to the benzene ring. Okay, this class we call it the phenols. Okay, now, if you were to look at your SIO, the first page of your lecture notes, you will notice that solubility in water is actually not inside. Okay, but that doesn't mean you don't need to know. Okay, you will still need to know because it is actually a concept for chem bonding. So questions can actually be tested on that as well, although it is not on the first page of your SIO. So this is something that you must take note of. Okay? Okay, so let's start. Hydroxy compound basically, okay, it's just an organic molecule with the OH group. Okay, a molecule with the OH group, we will call it the hydroxy compound. Okay, your alcohol. Okay, so this OH group is bonded to a alkyl group. And this one is what we call a phenol, whereby the OH group is now bonded to the benzene ring. Okay? Okay, so this one, if there is only one OH group, we call it the monohydric. If there is two or more, we will just call it the polyhydric. Okay? Okay, so just this is the general formula whereby it's CnH2n plus 1 OH. Just to take note, there is another class of compound called the ethers, which also have a similar general formula for you. Okay, but ethers is not in your syllabus. Okay, so you can have your ethanol, you can have your methyl oxide methane. Can you see? For ethanol, for hydroxy, the O is bonded to the H, whereas for ether, okay, if there is a chance for you to encounter, it is actually bonded to two R groups. Okay, but their general formula and their number of carbons, number of hydrogen will be the same. But there are two different class of organic compounds altogether. So something for you to take note. Okay, so this one is similar to your halogen derivative. You have also learned it before, okay, whereby we classify it whether is it in primary, secondary, or tertiary. So same thing with one R group, I call it the primary alcohol. Okay, no longer do I call it the primary halogen derivative or halogen because I do not have an X. Now the X is actually the OH, so I call it a primary alcohol. Same thing, two R groups, I call it the secondary, and if I have three, then I'll just call it the tertiary. So it is actually the same as what you have learned in your halogen derivative. Okay. Exercise 1. Time for you to put your brain cells to work. So can you draw all the possible isomers for the alcohol with this? Do take note that one of them actually have a stereoisomers. Okay? Okay, ready for discussion? I think most of you managed to get the primary, secondary, and tertiary, out of which one of them is actually the stereoisomer. So let's take a look. I have this molecular formula, C4H9O12. So you can check your answer. I think you have this, which is your butanol. Okay, and then this one, your 2-methyl propanol is also a primary, because in this part, in this carbon that is bonded to the OH group, I have one group, two groups, and then I only have one R group here. So this is also considered a primary. Then I have my secondary, which is here. Okay, but this one, you notice that there's actually a chiral carbon. So because there is a chiral carbon here, I can draw my two enantiomers. Okay, so just to take note again, when you are drawing your enantiomers, okay, for the CH3 is the only one that you can flip. The rest, please just draw it as per it is. OH, the small molecules, okay, OH, CH3. Anything that is your CH2, CH3, please don't flip, just draw it the same way. Can? So this is your secondary. And the last one will be your tertiary, which is this. Okay, so can you all need time to copy? Don't need, right? Most of you should be fine. Okay, so just some quick tips for drawing isomers. First thing, you try to vary the position of the functional group. Like in this case, okay, your alcohol, you can actually vary the at position number 1, position number 2. Okay, so you can vary the position. Okay, second one is either a straight chain or the branch chain. Okay, when it's straight or branch, I would like to highlight to you, please take note that you always try to name it to make sure that it is a different isomer. Sometimes you place your OH at different position, but if you look at the parent chain, it is actually the same. Okay, so it's actually the same isomer. So you might need to try to name it to make sure that it is different. Because as I walk around, I think some of you thought it's different, but actually it's the same isomer. So be careful with that. Okay, so these are just some very quick tips when you are drawing isomers. Okay, next, let's move on. Okay, let's move on to the physical property of alcohol. This is not new to you. You have already learned it before in chem bonding, but I would like to highlight it again so that you are aware the importance of it. So same thing, for physical property of alcohol, I have this butanol here with a OH group. Okay, so let's take a look at the boiling points. Do you notice that, okay, with a similar MR, the boiling point for an alcohol is very much higher than that of an alkane. If you look at the table in front of you, okay, and then the question will be, why does alkanes with the boiling point is so much different with compared to the alcohol with similar MR? Okay, I think the answer is quite obvious. If you take a look at the structure of an alcohol as compared to the alkane, you notice that alcohol actually does have the OH there. And with the OH, it can actually form hydrogen bonds as compared to your alkanes, which will only form ID-ID between the molecules. Okay? Okay, so in a diagram, if you're asked to show the hydrogen bonds, this is how you should show. Just a very quick recap for you again. Please make sure you show the partial charges, and the partial charges has to be in a pair, meaning to say I draw a delta minus here, I make sure I draw a delta plus. Same thing for here, if I draw a delta minus, I make sure I draw a delta plus. And I show the lone pair, okay, that is forming the hydrogen bond with the electron deficient hydrogen here. Okay, so I remember to label my hydrogen bond. Okay, this is from your chem bonding. So like what I mentioned just now, because of the hydrogen bonds is formed between the alcohol molecules, okay, which is stronger, so it actually needs more energy. This is actually inside your notes. There is no need for you to copy. Okay. Okay, if you want to copy, you might want to copy this hydrogen. Oh yeah, the hydrogen is also inside this diagram. You might want to highlight the important points to note when you are asked to draw a hydrogen bond. What are some of the things that I must remember to include in my diagram? Okay. Next, boiling points of alcohol. I'm comparing down the group, or not really down the group, but as the number of carbons increases. Okay, I also noticed that the boiling point actually increases. Okay, so this one is not so much about your hydrogen bonds, the different types of IDID. Okay, it's more of the different types of the intermolecular forces of attraction. This is more for the number of carbons. This one I have 2 carbons. This one I have 5 carbons. So between the molecules, okay, there is an increasing number of electrons. That's why the IDID part of it actually increases as well. So that leads to the increase in the boiling point. Okay. Can I move on? Last one. Okay, last one is about same molecular formula, okay, but different structure. It also leads to different boiling point. Okay, this is similar to your alkanes. In alkanes, you also have a straight chain and a branch chain. We also talk about that. It's similar here. This is butane 1-ol. This is a straight chain. This is actually more spherical in shape. It's a branch chain. So why is it that they have different boiling points? It all boils down to your surface area. Similar explanation as what you have learned in alkanes. Okay. Okay, so far with these 3 concepts, this is just a very quick recap for you. Let's move on to the next one, polyhydric. Okay, now instead of 1 OH in 1 molecule, now I have 2. Okay, for example, this one, I have 2 OH group. This one, I have 1 OH group. Okay, so you can look at the boiling point. There is also a big difference. Okay, so it's actually same thing because of the hydrogen bonds. This one, we are comparing the number of OH group that is present inside the molecule itself. So because this ethane 1,2-diol, okay, is able to form more extensive hydrogen bonds because there is actually 2 OH group present. Whereas for the propane 1-ol, I only have 1 OH group. Okay, so in terms of the number of OH hydrogen bonds that is formed will be lesser and hence less extensive as compared to my ethane 1,2-diol. Okay. So same thing, if it's more extensive, then I will need more energy. Okay, so this is more filling the blanks. If we are good, let's move on to solubility. Solubility of alcohol and water. Highlight to you the first 3. Okay, your methanol, ethanol, and your propanol. Okay, the solubility is infinite. That means it's very soluble in water. Whereas if you look down, now as the number of carbon increases, you will notice that the solubility actually drops. Okay, so as the number of carbon increases, the solubility actually decreases. Okay, so then the reason for it, why is this tree so soluble? It's actually because of the smaller MR. So the presence of the OH group enables them to form hydrogen bond. The non-polar segment of it is not so significant. Okay, so it is soluble in water. But as the carbon increases, okay, you will notice that as the number of carbon increases, the non-polar segment of the alcohol, okay, it actually becomes more significant. And because this non-polar segment is not so soluble in water, it actually hinders the formation of the hydrogen bond, and itself is not very soluble. That's why overall, as the number of carbons increases, okay, the solubility actually drops. Okay, so although this OH is still able to form the hydrogen bond with water, but because of the bigger non-polar group, okay, it hinders the whole formation of the hydrogen bond, and it makes it more difficult, so it's less soluble in the end. Okay, let's move on. So alcohols are miscible with most organic solvents. That is why they are usually used as a solvent. Like for example, your NaOH in ethanolic medium, okay, you actually uses the alcohol. Okay. Okay, we'll move on to the next one, which is your preparation of alcohol. That means from different functional group, how can I change it into alcohol using suitable reagents and conditions. So the first one that you have learned it before is actually the alkene changing to alcohol. Okay, this is electrophilic addition of steam under high temperature and high pressure. Okay, so this one you can get your alcohol as well. If you talk about in the laboratory, this is also what I've taken from your alkene notes. You can also do it in the lab, but what the change is that in the lab there is no high temperature and high pressure. So what we actually use is that we use concentrated H2SO4, okay, followed by heating with water. Okay. Next, to get alcohol, the same thing. You also have your nucleophilic substitution. This is what you learn in halogen derivative. From the OH will replace or will substitute your Br to give you your alcohol. Okay. Next one. This one is something that you have not learned. Okay, this is in the carbonyl topic, which is after hydroxy. You can also get alcohol from your aldehyde, ketones, carboxylic acid, and ester. Okay, all this can be achieved by using a reducing agent. Okay, so the previous one you have learned, but for D you have not learned it. So for aldehyde and ketones, okay, this is something for you to note. Other than using their lithium aluminum hydride, you can also use your sodium boron hydride, or you can use your H2 in the presence of nickel catalyst. Okay, this one is something that you'll learn in the next topic. Okay, so just to let you know as of now. Okay. Okay, I would also like to highlight, if you notice, in oxidation, we actually use O to represent oxidation, when you are learning alkenes or arenes, you actually use your O to represent your oxidizing agent, KMnO4. But in this case, if you are talking about reducing agent, you are actually using H, because oxidizing agent is adding O, reducing agent is adding H. So for simplicity purposes, instead of writing the lithium aluminum hydride, you can actually use the H. Okay, you can use the H to represent that. That is for your reducing agent. Okay. Okay. So this is something that you will learn again in carbonyl. So, but all these different functional group, different molecules, they can actually, by adding suitable reagent and condition, I can go back to my alcohol. So that is why it's parked under preparation of alcohol. I also hope that at this juncture, you are already halfway through your organic syllabus. I hope that you see the link between the different topics. No one topic is actually studied in silo. Okay, everybody or every topic is actually interlinked. So I hope that you can start doing your mind map, start to link the different topics together, so that when you finish your entire organic course, okay, you will see the big picture and you will know how to link different reactions together. Okay, so you can start doing already. You are halfway there now. Yes, you are halfway there now. Hang it there. You will be finishing soon. Okay, finish these two blanks. Okay, let's move on. This one is another one, ketones. Other than aldehydes, your ketones can also be reduced. Okay, but for aldehyde, you notice that you actually get a primary alcohol. But for ketones, you actually get a secondary alcohol. Because the nature of a ketone is whereby you have two R groups bonded to this C double bond O. Whereas for this one, aldehyde, you have one R group bonded to the C double bond OH. Okay, so this one will be reduced to a primary, this one will be reduced to a secondary alcohol. Okay, you can deduce from the compound that is given to you to help you to remember better. So this one is two examples where you can just reduce it to your alcohol. Okay, after talking about your aldehydes, your ketones, we will move on to the next class, which is your carboxylic acid. Okay, carboxylic acid can also be reduced, okay, to your alcohol. Same thing, if you notice, we all use the H to represent. Okay, so this is an example of it. Moving on to ester. Do take note that this is not in your syllabus. Okay, for ester, the reduction of ester, it will actually give 2 alcohol. Why is it so? If you look at it, this is a C double bond OO. This is the ester group. Okay, so when it's being reduced, it will actually break off here. And then you will get your R prime, which is this alcohol. And then this RCO will become a RCOH here. So that is why when you reduce your ester, you will actually get 2 alcohols. So when you cleave your CO bond here, you get R prime OH, and then this part here, you will get your RCOH. Can see? Okay, so this is an example for you. Okay, the last one, fermentation of alcohol, carbohydrates or sugar, basically is your glucose. You just ferment it, and then you will get your alcohol. Okay. Now, probably this one is more of a knowledge for you. Do you know that in some countries they actually use alcohol as fuel? Okay, in our country we actually use gas, use petrol, but there are countries which actually use alcohol. Okay, they call it the alcohol. Okay, can you see this one? More Brazil cars actually runs on alcohol. Okay, which is out of the traditional way whereby we actually use our fuel. Okay, whether is there more accident or not, that one I'm not very sure. Whether the fuel efficiency, whether is it as good as our petrol run cars, also not very sure. Okay, but they actually use ethanol to drive, they use ethanol as fuel. Interesting, right? Okay, so yep. So alcohol actually has many uses in our daily life, not just for drinking. Okay, it can also be used as a fuel. It can also be used as a biofuel. So yep. Okay, now just to give you another knowledge as we move along. Okay, this one is actually your alcohol consumption. Not for you. You are too young. I mean the older adults. Okay, they did a survey. Okay, they did a survey from 18 to 29. Yeah, they discovered that there's actually 18.7% of the men and 12.2% of the women. Okay, it's actually classified under binge drinking. Okay, what is binge drinking? Anyone? Oh, what does this mean? What's the definition? Okay, I go and search. What I understand is 5 cups in 2 hours. That means you drink 5 cups in 2 hours is considered binge drinking. Yeah, 2 hours you drink 5 cups actually is considered quite a lot. Okay, so yep. Is it a lot? No. Such a strong reaction. Does it mean it's not? Okay, this is just the survey that is done. Okay, now, shh, come back. Okay, actually, I'm trying to discourage you to drink alcohol. Why? Let me tell you why, okay? Let me tell you why. Okay, alcohol is actually eliminated from your body by various metabolic mechanisms, out of which, okay, in the liver, you know, right? People always say if you drink too much, you will get liver cancer or you get hardening of the liver. Okay, why is it so? Okay, it's actually because when you drink the alcohol, okay, it's actually oxidized to ethanol. That means the ethanol inside is oxidized to ethanol. And then this ethanol actually harm your tissue. And because of that, over a long period of time, okay, it will do something bad to your liver. Okay, so yep, alcohol is also known, okay, to cause cancer in many different parts of your body. There could be more, okay, but what I found is just this many. There could be many, many more because it goes into your bloodstream. It can affect a lot of different parts of your body. Okay, so yep, so please do not drink too much alcohol. No, I should say you cannot drink yet. Correct, you're 18 years old, you cannot drink yet. Heaven. Okay, so this one is also what I found. Okay, if you can go and take a look at this website. Okay, excessive alcohol consumption can also lead to fatty liver. Okay, fatty liver. Okay, I think you all heard before, right? Fatty liver. No? Do you hear your parents or sometimes when you're reading articles, fatty liver? Okay, so here they mention that alcohol intake for a few days can produce fatty liver, which are found in, I think all these are bio terms, which is I'm not very familiar with it. Okay, so bio people probably can understand it a little bit better. So, next thing. Can you see alcohol does affect a lot of your body parts? Heart failure, kidney failure, okay, and then your brain damage. Okay, so basically alcohol is something not good. Okay? Interesting, right? Never knew about this. You can go and read up on it. Okay, now this one. I think this is something interesting. Okay? I think a lot of people, sometimes after drinking, you are a bit red. Okay, or you look very red. Okay, what is actually happening here? Okay, what is actually happening is that actually, okay, you actually have a symptom. Okay, I'll just read out what I found. Okay, it's called Asian flush syndrome. Okay, whereby your body, okay, as your body, your face, okay, actually have a accumulation of the acetaldehyde, which is this one. This one, okay, accumulation of this. That's why your face will look very red. Okay, so this one, and then, yeah, so you will look very red. Okay, and then some people, you actually puke. Okay, I think some of us actually puke after drinking alcohol. Okay, why is it so? Okay, why is it that you puke after drinking alcohol? Actually, I also go and do some reading up on it, and I discovered that the brain, okay, there's actually a place called the vomiting center. Okay, they put it as vomiting center. So what does it mean? It means to say to the body, this is actually considered toxic. So because it's considered toxic, when you hit a certain level, then the body will just blah, everything come out. Okay, yeah. Just like when you have food poisoning, when you eat something wrong, then you will just blah, everything come out. So it's the same. To the body, the alcohol is considered toxic. Okay, so yeah. So that is some of the reason why people feel red and then why people puke after consuming alcohol. Okay, so yeah. So this is just some knowledge for you before we go back to the next bit about alcohol. Okay? Okay. Shh. I'm good. So you can go and read up. If you're really interested to know more, just go and Google and read up to know more about it. So just a quick recap, what we have done so far. We have done boiling point, solubility, method of preparation, how to get your alcohol via different methods. Okay, so now what we are moving on is actually the reactions. Okay, reactions of alcohol, basically your combustion. Okay, your cleaving of your CO bond. Okay, cleaving of your OH bond, and the oxidation. Okay, some of which you are actually quite familiar with it. You have learned it before. It's just a different functional group. Okay, to get a different compounds. Like oxidation, you have heard it before. Acid base, not acid base, acid metal, you have heard it before as well. Combustion, you are also familiar with it. Okay, so, yep. Combustion, first one, combustion. Okay, it burns with a clear hot flame. Okay, and then you produce your CO2 and your water as usual. Okay, when all organic molecules, when you burn it, it will just give you your CO2 and your H2O. It's just a matter of whether I will burn with a soot, that's all. Okay, video, show you a video time. Okay, this one is the combustion of the methanol. Where? Here. Is it on? Okay, wait. So next time, if you go to the pub or something in the future, please don't be a hero and try to drink a tequila shot or something with a flame on it. Okay, basically what the point that he's trying to say here is that alcohol burns readily, okay, and it catches fire very easily. So when the person is drinking, okay, there is actually alcohol inside his, the mouthful of alcohol. That's why the fire is still burning there. Okay, so please be careful with alcohols, okay, when you are dealing with it. Okay? Yep. Okay. Shh. Back to lecture proper. If I have an alcohol, this one, I will be able, if I use excess corn, H2SO4, I heat, I will be able to get an alkene. Recall, this is also the reactions that I use when I want to prepare alkenes. When I want to get alkenes, I actually use alcohol, excess corn, H2SO4, a dehydration reaction. The type of reaction is actually elimination. Okay, the type of reaction is elimination. Okay, then you can get your alkenes. Okay, so this one you can just refer to your alkene notes. Okay, for your major and your minor product, your Zerzev rule. The more substituted alkene will be the one that is favored in the formation. So just a quick recap, here I have 2. This one I only have 1. Okay, this one I have 2, this one I only have 1. So this one is the more substituted one, and this one will be the major product. Okay, not sure, can go back to your alkene notes again. Okay, so this one is the same thing. This one is forming of your ether. Okay, if I have 2 alcohol molecules together, I can actually form an ether as well. Okay. Okay. I would think I will stop here. I will talk about all this again another lesson. Okay? So, yep, that's it. Thank you.